Hello, everybody, and welcome to the Smart Human podcast. Today, we are speaking with Dr. Laura Kahn, who is the physician and research scholar with the program on science and global security at the Princeton School of Public and International Affairs at Princeton University. She has multiple degrees as a doctor, nurse, master's in public health, and she's an expert on global policy. So we're going to talk all things, of course, global policy, bacterial resistance, climate change. We're talking about our animals and pets and how this all plays out, as well as with COVID-19. So stay tuned and hope you enjoyed this wonderful interview with Dr. Kahn. Hello, everybody, and welcome to the Smart Human podcast. Today, I have a very special guest. Not that all of my guests aren't special, but this person is a really special person because we know each other. And she is in our town of Princeton, New Jersey. She is Dr. Laura Kahn, and she is a physician and research scholar with the program on science and global security at the Princeton School of Public and International Affairs at Princeton University. She also has a number of degrees, which I reviewed this morning. She has a nursing degree from UCLA. She has a medical degree from Mount Sinai in New York. She has a master's in public health from Columbia University and an MPP from Princeton University, which I have no clue what that is. So hopefully she'll be able to share with me what an MPP is. So welcome, Laura. Thank you so much for being here and taking the time.
Thank you. It's a real pleasure. Thank you for the invitation. I really appreciate it.
I was waiting for this for a very long time because I already sussed out who my smarty pants people I wanted on the show to explain a lot of cool topics. So first, tell me what an MPP is.
An MPP is a master's in public policy. And that's a degree from the government school, the Princeton School of Public and International Affairs. So there's a 2-year program, the Master's in Public Administration. So it's the government version of an MBA, a Master's of Business Administration. This is for mid-career professionals. The MPP is the Master of Public Policy. So looking at what governments do or don't do.
Wow. Okay, that's really interesting. You're like a lifelong student. I think you went more for the most degrees than one human could get in a lifetime. So tell me, we have some stuff I definitely want to cover. I mean, look, it's COVID-19, so gosh, it couldn't be more relevant to have you on the show. So I'm going to kind of, ask some of the questions that you probably have been getting a lot, but really are pertinent to our time and life now on Earth. What is a zoonotic disease? And why is that important? Sorry, go ahead.
Right. So a zoonotic disease is a disease of animals that can infect people. So, for example, influenza, pandemic influenza is a zoonotic disease. Obviously, SARS-CoV-2, the original SARS, MERS, the Middle Eastern Respiratory Syndrome, zoonotic. Most of the diseases that cause pandemics were originally zoonotic, meaning that they were spillover events spreading from animals to people. And in fact, one study done in the it was around 2003, determined that over half, about 60% of all human infectious diseases are caused by zoonotic agents. And of the newly emerging diseases, about 75% are zoonotic in origin. So these are extremely important diseases, microbes, that we need to be doing surveillance of. And that led me to this whole One Health concept that human, animal, and environmental or ecosystem health are linked. And we interact with our environment every day. We inhale the air. We drink the water and other fluids. We literally eat plants and animals. So we ingest the environment into our bodies, but we don't generally think about it that way, but we do. And so we live in a microbial world. These microbes get around. We have microbes living on us and in us. The plants and the animals have microbes on them and in them. The whole planet, as I said, is microbial. And so we get these microbes on us and in us all the time. But we generally don't think about it that way. So zoonotic disease then is a disease of animals that affects us. Sometimes they don't cause disease, but sometimes they make us really, really sick.
And we've been evolving. I mean, essentially, humans have been evolving for over 4.5 million years around that time, more or less, depending on how you look at it. And, we never even bothered to look even in the gut until maybe 20 years ago.
That's right. That's right. And it's really fascinating because technology has allowed us to do that. So in the 80s, there was this whole new field where you were able to look at the microbes, the genetic material in the environment. They were studying the ecosystems. Most of what goes on under the soil surface, we have no idea because a lot of the microbes can't be grown in the laboratory. And so people came up with this really clever strategy called metagenomics, where you extract DNA directly from the environment. And when they do that, just a whole bunch of really interesting things appeared. For example, they found that there were antimicrobial resistance genes everywhere, and that they are ancient, they are global. And I'm now starting to go down a whole tangential path.
That's okay because I'm following with you. And so, in terms of antimicrobial genes, what does it mean to be antimicrobial, and why does that actually matter when they looked into all of this?
Well, it matters because we rely on antibiotics to treat bacterial infections. And the problem is the bacteria are evolving. They're sharing these resistance genes with each other. They're evolving to evade the antibiotics so that they are no longer effective. So infections that were once treatable are becoming untreatable or incurable and possibly fatal. I mean, we are possibly returning back to the pre-antibiotic era. So that's a huge problem. That's a One Health problem. We need to look at it from the perspective of humans, animals, and the environment. And usually what we do is we just focus on the humans. And so we're missing a big piece of the picture. Because the fact that these resistance genes are ancient and everywhere, it's not like they just kind of developed from a vacuum. It means that we're doing something to the environment to change what's called the global resistome, or that we're changing the biome of the planet in ways that we don't really understand.
And so, what are those factors? Like, tell me a little bit about why zoonotic disease really emerges from animals and kind of makes its way into human life and communities and bodies.
Right.
Yeah.
Well, it stems from our interactions with animals, whether they're domestic or they're wild. I mean, what's our interactions? We generally eat them. That's about as profound as you can get in terms of interacting with another creature, is eating it. But we also keep them as pets. When we domesticated animals for food security during the dawn of agriculture, we domesticated plants and animals for food. That had many pluses. It provided food security. It reduced hunger. It allowed the development of towns, cities, and nations to grow. I mean, everything that we take for granted in our civilization is because of agriculture and the fact that we're not spending all our time looking for food. We're able to sit here and talk about food rather than having to spend all our time looking for it and trying to grow it. So that was really profound. And by doing that, though, we started changing our environment, because in order to have agriculture, you need to clear out the land to be able to, plant acres of crops. So you cut down the trees, you clear out habitats. And as our numbers are growing, there's now, 7.5 billion people on the planet, and they're estimating going up to 10 billion. Everybody has to be fed. And there's only so much arable land on the planet. And on top of that, because of global warming, our climate's changing. And we relied on a relatively stable, mild climate to be able to have agriculture. I mean, it's not a coincidence that agriculture began about 10,000 years ago, right when the temperature of the climate of the planet reached a baseline that was kind of like in the Goldilocks zone. Before then, during the Ice Age, it was much too cold. So you couldn't have agriculture back then. You have it now. And we've had fairly stable, mild, predictable climate where the farmers would know when to plant the crops and when to harvest them. There were a few deviations, like the mini ice age during the Middle Ages, when you had severe weather events. And it's interesting that one author of this book, called Nature's Mutiny, found that when you had these severe events, weather events, with crop failures and famine, well, somebody had to be blamed for the divine intervention, and it was usually poor elderly women who were called witches. They would be accused of cavorting with the devil, causing the crop failures, and so they would be punished. So it has a profound impact on society. And don't think that, we still have scapegoats, people who we blame for our problems. That doesn't change. And now the planet is warming up about 1 degree above this baseline that we've had. And so for me, the greatest concern that we face from climate change is our threat to the ability to grow food, grow crops, feed ourselves, and the risk to agriculture and food security.
And you actually, I guess in 2006, had kind of like a really important paper that was published that really kind of launched you into One Health. Is that right? What was that paper, and why did it get so much attention?
Well, so the paper was called Confronting Zenoses, Linking Human and Veterinary Medicine. And I wrote that after doing a several-year study looking at the infrastructures of several states, looking at whether or not their departments of health interacted or communicated with departments of agriculture, and looking to see if physicians and veterinarians communicated with each other. Because since these microbes go between humans and animals, the microbes don't see a difference between us and the other animals. They just want a nice warm body to inhabit. But we put this, arbitrary barrier between us and all other life on the planet. And as such, then we put we've created institutional silos. So there's the silos in academia, there's silos in government, and there's silos in business. And so we are not structured to be able to handle these species microbes that go back and forth, or that develop the ability, or they evolve the ability to infect one species and then another. And so when I discovered that the departments of health and agriculture rarely, if ever, talked with each other, and physicians and veterinarians rarely, if ever, talk to each other, and in fact, medicine has become so specialized that they see no relevance of this whatsoever to their practice, and they're just not interested. I mean, our whole training does not prepare us for the reality of what we're living on in this planet. You're just focused on one organ system. We're not looking at the big picture. Nobody
I feel the same way about environmental chemicals, which again is not so different from One Health, because we're not looking globally at what affects human health. We're looking at just very insular, small, textbook driven, information, without really opening our eyes to all of these influences that are all interactive.
That's right. So, again, these chemicals, they interact with us whether we inhale them or we inadvertently drink or eat them, or they get them on our skin. I mean, somehow the environmental contaminants that we create get back to us. But we generally are not taught that. When you are in medical training, you've got the patient sitting in front of you, in front of the clinic, or in the clinic setting or in the hospital, and you don't look at the environment in which they live. They are just a series of organ systems. And which organ system am I going to focus on? And we've specialized now into just organ systems. And so nobody goes into general internal medicine anymore or family practice. And even then, you tend to specialize. So nobody's putting together the big picture.
Yeah.
Now, the veterinarians get very different training. The veterinarians learn about the environments in which their patients live because their patients live outdoors. And they get, into all sorts of parasites and microbes and things. We think that our indoor environments protect us from everything outdoors, but that's not the case. We think that our homes and our offices protect us from the whole environment in which we live, and that's not the case at all. The environment comes in whether we like it or not.
Right. We're living it right now. We're living it. The four walls don't block COVID. I mean, we know that it's getting into our system through a lot of different means. We're learning about it now, but
right. It's airborne. It's airborne.
And so we got to think about that. But even the microbiome, it's interesting you say, when chemicals affect the gut, it kills off very non-pathologic bacteria that we've evolved with that keep us healthy, keep our immune system, our endocrine system healthy. Now we have PFAS chemicals that are affecting our response to vaccinations and affecting our immune system through that process. And, just expanding on this whole, antibiotic resistance, where we don't respond in a good way to antibiotics when we actually need them.
Yeah. Well, along that line is you can kind of think of antibiotics like pesticides because they're killing off the good with the bad. Now, I'm not saying that antibiotics haven't been important in saving lives. They have. They've saved untold numbers of lives. But on the other hand, as we're learning more and more about our microbiome and the importance of these microbes in our health and well-being, by killing off just kind of the shotgun approach where you're just killing off everything in the hopes of killing off the bad microbes, you're also killing off a lot of the good microbes. And so what we're finding then is that a lot of some of the diseases that we're being afflicted with, autoimmune diseases, food allergies, even obesity and asthma have been attributed now to potentially antibiotic use. There's a great book by Martin Blaser called The Missing Microbes that's really important because he has done research into this. And so we can think of, the use of antibiotics as kind of like a pesticide where pesticides have been extremely important for, reducing our risks of insect pests, destroying our crop yields. But that comes with negative, consequences of, these are poisons. And if you eat them, that's bad for you.
And it's not just, a lot of people want to blame doctors for overprescribing, which is certainly one aspect. But we also have, really an untold amount of antibiotics that are used in manufacturing of animals, of feedlots and chicken farming and beef and cattle farming and pigs. And we really don't realize that 80% of our antibiotics, correct me if I'm wrong, are really used in livestock, in managing livestock in the United States. I'm not sure what that number is around the world. You can tell me.
Well, you have to be careful with that because a lot of the antibiotics that they use in agriculture are some of the older antibiotics that are generally not used in human medicine anymore. And don't forget, they're also using antibiotics in plant agriculture. That's huge. Glyphosate, for example, is a chemical that has some severe health consequences. So it's not just the animals. But look, you don't want to eat a sick animal. You want to eat a healthy animal. And if the animal develops a bacterial infection, you want to treat it. You don't want the animal to suffer. The whole challenge that we face is we have to figure out how to sustainably feed ourselves, meet our, dietary protein, nutrient needs. We have to do it on a warming planet with diminishing resources without destroying more of the natural world, and without unleashing more deadly diseases upon ourselves. I mean, it's a really tall order that we face, and we're not talking about this on a societal basis because we're so busy just pointing fingers at each other, blaming each other for this and that. I mean, we really need to come together as a global community and figure out how to sustain ourselves. And right now, it's just tragic that we don't have the leaders in place to do it. I mean, it really takes goodwill, collaboration, cooperation, and we're not getting that right now, just when we need it the most. So,
Yeah, it's a little daunting to say the least. And Princeton University, is really one of the leaders, I think, in climate change and really pushing conversation forward. They have a conference, I believe, every year and that kind of thing. But it's the communication between entities like Princeton University and governments, and really putting that academic information into actual play in
well,
policy.
yeah, well, it would help if we had a government that believed in science right now. I
Right.
mean, these past, 3.5 years have been really uh, distressing, to say the least, when all of these problems are happening and there's just nobody interested at the government level to discuss it.
Yeah.
Um, and so, how do you address it if you can't even discuss it?
And I'm always interested when scientists voice their opinion, because, I think for so long, many people have kept their opinion. And I don't look at this as politics. I look at it as science. Whether it was a Democrat or Republican that was leading our country or part of our municipalities, if there's an environmentally driven problem that affects human health, there needs to be some change, whatever their politics technically are. And so I'm always really impressed, especially now when we need scientists, real scientists, to speak up and get loud about these issues because there's no other time to do it.
I couldn't agree with you more. I mean, one of the challenges in this age of anti-science is that people don't want to believe what you're saying if they've got preconceived perceptions. If they don't want to believe that something like vaccines or certain medications are effective and safe, no amount of data is going to convince them. People are hardwired for stories, not statistics, and you really have to get to their heart, their mind, and their gut, rather than just spouting off statistics to them. And
So,
that's a tall order because as
yeah.
scientists, we're not taught how to really engage the public in this way.
Yeah, you have to almost meet them where they're at. I mean, it's kind of my frustration out of environmental health that I got into the Smart Human because I felt like it needed to have sort of a sexier feel for the average person, to really buy into, the information. It had to feel like, it was going to affect them directly, that it affected their lives where they're at, not something, high up on a hill where it was too unattainable to understand and the language wasn't relatable and the life wasn't relatable. So what do you think needs to, I'm assuming that's also why you launched One Health Initiative, which is really bold. And you really are bringing this into the forefront. I mean, you're making this into something that really people listen to, and you're making it conversational, and you're bringing out real information, I think, on social media in a whole bunch of ways. Tell us a little bit about how that's been going since when you launched it, and also what your goals are for One Health.
Well, since we launched it, it's been primarily driven by veterinarians. It's been, that's the community that recognizes it the most, and that's been pushing it the most. We had a terrific leader in medicine. His name was Dr. Ron Davis, past president of the AMA, American Medical Association. He was the first preventive medicine physician to head up the AMA. And tragically, 1 year after we were able to pass a One Health resolution by the AMA, recognizing the importance of this concept and committing themselves to working with their counterpart, the American Veterinary Medical Association, he developed pancreatic cancer and died within a year of that event. And he was a young man in his 50s. And I can't tell you how tragic it was for of course, his family, but it's been a huge hit in terms of the drive of One Health in the medical community, because we need prominent leaders like that to help propel the concept forward. And I mean, we have a few medical colleagues, Dr. Barbara Natterson Horowitz, who's a cardiologist and psychiatrist. She trained at UCLA. She wrote the book Zoobiquity. And that was a fascinating book that focuses on the conservation of disease processes across species. And just to give you an example, she volunteered at the Los Angeles Zoo doing cardiograms on monkeys. And there was a tamarin monkey that she was doing an echocardiogram on, and she noticed that the monkey had very pretty green eyes. So she was staring at the monkey's eyes as she was doing the cardiogram. And the veterinarian said, please don't stare at the monkey's eyes, because the monkey thinks you're going to eat it. Because if you stare at an animal's eyes, it's a very aggressive movement. And she was really taken aback. And the reason why is, if you stare at an animal's eyes, if it goes into extreme stress, if it gets captured, for example, it can go into what is called capture cardiomyopathy, where it goes into extreme stress, it goes into sudden heart failure, and it dies. And she was absolutely stunned, because there was this new medical condition that was just discovered by Japanese cardiologists called Takasohu's cardiomyopathy, where somebody goes through extreme stress, like the death of a loved one or some other crisis. They go into sudden cardiac failure and die. Well, the veterinarians described this phenomenon in the early 1970s. And the physicians didn't discover the same phenomenon in humans until the 2000s, 30 years later. Now, just imagine if we had been talking to each other, the physicians and the veterinarians, and recognized that this disease process is conserved across species. And there's many, many other examples that she highlights in her book. I mean, she focuses primarily on cardiology and psychiatry, obsessive compulsive behavior, anxiety. You see this in all the animals. We don't think of ourselves as part of a continuum, but we are.
It's interesting you say that, because first of all, when you said that about staring at your animal's eyes, I mean, my dog and cat must be having heart attacks pretty much 24 hours.
Not when they're domesticated.
Oh, okay, good.
So the dogs have evolved with us for over 15,000 years.
Okay. Now I feel better. I feel like I'm not.
Don't worry about your dog. Your dog is a sign of love.
Okay, thank you for clarifying, Laura, because that was really, I'm starting to panic.
Yeah, this is wild animals.
But I talked with my vet, my cat vet, who comes over, and we're always kind of throwing information about stuff to each other, and I'm always fascinated because we're throwing articles to each other as well. And I said to her, this phenomenon about the wasting cat syndrome, which made it to the New York Times, the front of the New York Times, as a story, because what happened was, people started noticing their cats were getting super, super thin, and their heart rates were going up. They were getting tachycardia, and they were losing muscle mass. And there was all sorts of these problems going on. And there was a couple of vets, I believe, I'm not sure the name of one or two that really stood out, but they started to talk to each other and realizing it became a syndrome. And when they somehow figured out to measure the blood level of flame retardants in their bloodstream.
Oh, wow.
I'm pretty sure it was mostly flame retardants. I'm not sure if it was phthalates as well, because we know those are tested in humans as well. It really became surprising that the cats that had these wasting syndromes and got really thin out of nowhere for no reason, stopped eating, were really high levels of household industrial chemicals, things that we use every day in our home. So cleaners and flame retardant chemicals that come off of our couches and off of our TVs and cables and in the dust. And what is their hand to mouth behavior, right? They're always licking their paws, just like our children,
Well,
toddlers.
exactly. These animals are great sentinels. So there's a whole field on, animals as sentinels. My colleague, Dr. Peter Rabinowitz at the University of Washington, runs a One Health Institute. He's an occupational environmental physician and has done a lot of research in looking at animals as sentinels. They're smaller, they have a shorter lifespan. They make perfect sentinels for like lead poisoning in the home and other, toxic chemicals like what you just highlighted with the phthalates. And oftentimes you'll see lead poisoning in the pet and lead poisoning in the children because, the kids are crawling around in the same environment. But we ignore the animals.
Yeah.
I mean,
if it wasn't for conversation, this is how I got into environmental health. My dog got sick. I did a TED talk on it because it was all about my shock and awe about this dog getting an autoimmune hepatitis that dogs don't get.
Right.
And it just blew my mind. But when I started hearing about these cats getting hyperthyroid because of the endocrine disruption of these environmental chemicals that we live in,
right,
we get into our skin and our children absorb. I think it was a real wake-up call that connected a lot of our animal life to human life in a very, kind of sexy, public way. And the fact that the New York Times took that on, I was just astounded. And I was glad. I'm hoping more of that connection comes through because we hear about fish and zebrafish and snails, and we hear about things that don't always relate to our day to day. But when you talk about your cat and your dog, it hits you right here. You know what I'm saying?
There's a great story about the dancing cats of Minamata, Japan. Are you familiar with that one, with the mercury poisoning?
Yes.
These cats were exhibiting these bizarre neurologic behaviors. They looked like they were dancing. Nobody knew what was wrong with them. And then people started getting sick, with severe neurologic problems. And, it was the cats that really helped to identify the causative agent because the cats were eating fish from the bay, Minamata Bay. And lo and behold, the nearby chemical company was dumping its toxic compounds into the bay, and everybody was getting this neurologic disease. And, it's just this horrific story.
Yeah, it's worth looking up if you're interested, if you're listening to this, because that story was profound and it wasn't reversible. And it was like a whole generation in that town was just lost to illness or death.
Right. Yeah.
You're right. It started with the cats, and it was just like they were fascinated by it. It was just so interesting until all of a sudden humans started having these weird things. So
the same thing happened with the West Nile virus outbreak in New York City. We had crows that were exhibiting neurologic abnormal signs, behaviors. Nobody knew what to do with them because they were wild animals. And then people started getting sick. But the animals started getting sick about a month before the people started getting sick. And it wasn't until the animals in the Bronx Zoo started getting sick that the veterinary pathologist at that time, Dr. Tracy McNamara, started doing necropsies, the animal version of autopsies on some of these wild animals, particularly birds. And she found this horrific hemorrhagic carditis, encephalitis, severe bleeding around the brain and the heart. And she started getting scared because she didn't know if this was potentially something that was, zoonotic, could spread to her and to her staff. So she called the CDC, the Centers for Disease Control, saying, I think my bird specimens, my exotic birds that are dying here at the Bronx Zoo have some relation to the outbreak of what was then considered St. Louis encephalitis in Queens. That was the presumptive diagnosis because it was, St. Louis encephalitis is endemic in the area, mosquito-borne. And the CDC said, well, you're a veterinarian. We only care about humans. We don't really care about animals. So we suggest that you call the ag lab in Ames, Iowa. And they hung up on her. And she was livid. Tracy McNamara is somebody who doesn't take no for an answer. So she called up a colleague at the U.S. Army Medical Research Institute for Infectious Diseases, told him her story, and he said, send me your samples. samples. So she did, and they determined that it was a West Nile virus, first time ever found in the Western Hemisphere. And the reason why she played such a key role is because you had differing susceptibilities of the different zoo animals. So since West Nile virus had never been seen before in the Americas, and the zoo animals, the zoo birds that were getting sick and dying were the birds that were native to North America. Now, if the virus had been St. Louis encephalitis, which was the presumptive diagnosis in the humans, the animals that were native to the Americas should have been immune, but instead they were sick and dying. The birds that were native to Europe and Africa, which should have been the ones sick and dying, because if it were St. Louis encephalitis, they would have never seen it, but instead they were fine. So they were the ones that were immune because this virus came from Africa and Europe.
Wow.
So, she put two and two together and knew that it had to be a new virus. And so was not deterred when the CDC hung up on her. Now, the CDC, to its credit, recognized the great mistake it made. And since then, it has established an office of zoonotic and vector-borne diseases, zoonotic, enteric and vector-borne diseases, as well as a One Health office headed by a veterinarian.
Wow.
They are, they're on top of this as best they can, but their funding is minimal. And that's another whole story in terms of One Health policy. Our whole government really isn't set up for doing surveillance of these zoonotic diseases. We focus on humans, or as Dr. McNamara likes to say, we use taxpayers as sentinels and not the animals. We wait until they get the taxpayers and then we do something.
And all of this sounds reminiscent of Rachel Carson's work. I mean, now we're looking back, is this full circle again? I mean, this is crazy that we're now back to, Rachel Carson in the 1960s, I think it was.
Right.
She was a biologist, I believe, and she was incredible. And she wrote the book Silent Spring, where she noticed that birds were dying off, and it was in relation to a lot of pesticide spraying. I think their fertility was decreased.
The eggs were being destroyed.
The eggs were thinner in terms. So she really picked up on something environmentally induced and really shouted to the world that we got this problem and what's going to happen down the line. And here we are now in 2020. It's almost a sad irony that we're here talking about this again, but we've been fair warned, in many ways.
Well, the chemical company was demonizing her because, that's their business model. And so, in all of these crises, you've got the interest of public health versus the interest of, the corporate world, whether it's agriculture, chemical companies. There's always some business interest that's being threatened. And their interests usually take precedence until there's enough public outrage because there's deaths involved, widespread deaths. It's only until you reach a certain level of public outrage that you actually get government response. Now, the tragic thing about this current pandemic of COVID-19 is we have over 170,000 people, Americans, have died, and we're not seeing the level of outrage that we should be seeing because of the government's fumbling of this response. And they fumbled in so many catastrophic ways. We could spend an hour just talking about that.
We need alcohol. I need something to drink if we're going to go there. So, but you're right. And 170 now, right now it's, I don't know, we're taping this in August 21st. We don't know what the next 2 weeks or 3 weeks are going to show in terms of that, because we now have the flu, the influenza virus, which we hopefully get our flu shots to help to help our protection. But again, one on top of the other. So we don't really know where this is heading, but we know that it's probably not anywhere good for at least a little while.
A national face mask mandate would do a lot. to help reduce the numbers.
Yeah.
And we just don't have that. I apologize. My dog is having nightmares.
That's okay, but at least he's not having any, God forbid, myopathy from staring at him. I mean, I don't know. It's seared into my brain now. So I have a couple other questions that I personally am very curious about, given chemicals and my interest in how chemicals affect human health. We have right now with COVID this sort of similar to antibiotics in our food. We really do have this spraying of disinfectant cleaners,
Right.
versus just cleaning material. We have disinfectants. And I tried to lay that out in our upcoming book about the difference. But I'd like to, if you want to comment, we have sort of this spraying with abandon, foggers everywhere. I think in India, they're using drones over townships to literally drop pesticides. And we know there's no regulation in the United States, any great degree of regulation on these chemicals. And so what are your thoughts in terms of that?
Well, I mean, we don't need antibiotics in our cleaning because, I mean, soap is inherently antibiotic and you don't need to add antibiotics to the product. Um, there's pluses and minuses to everything. I mean, look, there's been a number, you've heard of the dirt theory of autoimmune diseases.
Well, tell us what the dirt theory is.
Well, I mean, we evolved, our microbes evolved, our gut microbes, our microbiome evolved to handle an environment in which we lived out in the wilds, dealing with parasites and all sorts of things. And we have a very robust immune system that's used to working hard. And by living in these, in our indoor environments where we're spraying everything down, there's been some argument that, we're not giving our immune system enough to do. And so by keeping it bored, it starts attacking ourselves. And so a lot of our autoimmune diseases, whether it's food allergies or, asthma, I mean, interestingly enough, there's no asthma during the COVID pandemic. The number of hospitalizations have plummeted. And the number of preemies being born has plummeted because of COVID-19. So there's profound environmental conditions going on affecting our health and well-being that we just don't know about. And this pandemic is actually giving us a window into seeing what happens, under these extreme conditions. So there is much that we don't know, but the amount of funding that we get to study these things from an environmental perspective is peanuts, because we're focusing so much on just looking at, we're using genetically modified rodents to model human disease, artificially inducing human disease, and then trying to figure out, how to treat it from that. And that is such an artificial condition. It's not going to tell us the key things that we need to know. And one study that's being done now, and I'm happy to say that my dog is part of it, is the Morris Animal Foundation Golden Retriever study, which is the canine version of the Framingham study that was done in the 50s. You've got 3,000 golden retrievers. Now, golden retrievers are particularly prone to cancers. The breed is just known for that. And so they're following 3,000 golden retrievers from puppydom to death, looking at every aspect of their life, taking clinical samples. They get in-depth physical exams once a year. You have to fill out this lengthy form every year, tracking them to see, what cancers or what diseases they develop. Now, my dog has already developed one skin cancer when he was a puppy. He developed a basal cell carcinoma, skin cancer, on his back that had to be removed. So
that is fascinating. And in fact, it's almost making me want to cry because my Truxton, who died was autoimmune hepatitis. And that, my vet said he'd never even seen that in a golden or
Yeah.
even moose dogs. But cancers, I grew up with goldens and they all had cancers. I mean, that we know that they're the best dogs in the world, but they're also the ones that live the shortest lives, which is just such a sad thing.
It's really tragic. Well, apparently the one of the founding males of the breed was a great dog but died young of cancer, and it's possible that his genetic defect has been propagated through the generations of all the goldens. You have to think of these breeds as very inbred isolated humans, so they're a great resource to study because their lifespans are shorter. And since the breed has certain characteristics, there are certain dog breeds that are more prone to certain diseases than others. Some dogs are prone to epilepsy, for example. Other dogs are prone to kidney failure. And so using these breeds to study can tell us a lot about, there's human counterparts to it.
And Goldens have a whole pedigree that you can follow back probably to the first King of England, because everyone is so, especially if they're AKC registered, all that business, their lineage.
Right.
Which you can't say that about a lot of different, a lot of breeds are that way too, but I know Goldens are specifically, watched and kept records for.
And not only that, but these animals share our home. So they're sharing our environment. They're beloved animals, parts of the family. So it's not like they're being kept in a cage in a laboratory. So, people.
It's real world existence.
So it's real world experience. It's naturally occurring. This is the kind of study that more of what we need because it reflects on our environment. And it can, we share a lot of our genome with dogs, by the way. So there are counterparts from canine to human diseases. So here's another example of an animal as a sentinel that we need to be taking more advantage of.
Wow. And who runs that study? Because I want to look that up.
That's the Morris Animal Foundation Golden Retriever Study, and there's been a number of articles written about it.
I'd love to see that. So tell me, I know we're sort of winding down, but I definitely want to get a few more things in. 2016, you came up with your second book you wrote, One Health and the Politics of Antimicrobial Resistance.
Right.
How was that received? And, what are your thoughts on that moving forward since it's really so relevant?
Well, the veterinary medical community just, really embraced the book and thought it was great. And the medical community, zero interest. Zero interest. I think I've given one or two talks to human medical audiences. Most of my talks have been to the veterinary medical audiences. It's just been very striking. I looked at, the use of antibiotics in humans and animals and the whole environmental component, which was for me the most profound because of this, this existence of the global resistome and how, antibiotic resistance genes are everywhere and, in places that have never even experienced any human antibiotic exposure. And so, what we've been doing is we've been tracking resistance genes like the color of our hair, for example. So, if you have red hair, you have the gene for red hair. And what we've been doing by tracking resistance genes is akin to putting a whole bunch of people with red hair together and trying to figure out how they're related to each other based on their hair color. Okay, you can't do it. They all might share the red hair gene, but that doesn't mean that they're genetically related to each other.
Right.
So what you have to do is you have to sequence the entire genome of the human or the animal to be able to determine genetic relationships. Who's related to whom. And so when you do that with some of these resistant microbes, some very interesting things happen. So, for example, you heard the term "follow the money." So in the research for this book, there was one bug that stood out above all the rest. and it was called vancomycin-resistant enterococcus faecium, or VRE for short. The rise of VRE generated alarm bells around the world. And the reason why it was so concerning was because it was believed that it arose from the use of this drug called avoparcin, which was used extensively in Europe as a growth promoting agent in livestock. Okay. Avoparcin and vancomycin are in the same chemical family. So it was just assumed then that that was the cause of VRE, both on the farms and in the hospitals. But there was a very interesting thing that happened, though. So avoparcin was used in Europe extensively since the 1970s, but the United States never approved it. So avoparcin was never used in the United States. VRE is a huge problem in Europe, and VRE was also a huge problem in the United States in the hospitals. But if you did surveys, they did surveillance on the farms, there was zero VRE on the farms. So there was no way that VRE came from the farms in the United States. So what happened? What was this conundrum? You had VRE, and when they banned the use of avoparcin in Europe, you saw a dramatic reduction of VRE on the farms, but it had no impact whatsoever in the hospitals. So there was a real disconnect then between what was going on in the farms and what was going on in the hospitals. So when they did whole genome sequencing of VRE, a very interesting thing appeared. They discovered that the VRE on the farms and in the hospitals were two completely separate populations. There was one animal that they discovered that appeared to be the genetic precursor to the VRE in the hospitals, and that was dogs.
It was
dogs. Yeah, so nobody talks about our pets as potential reservoirs of resistant bugs, but there's a couple studies done in Denmark and other studies by the veterinary community that raised concern about VRE coming from pets, particularly dogs. One clone, VRE CC17, found in the hospitals, the predecessor to that, appeared to be ampicillin-resistant enterococcus faecium CC17 isolated from dogs. So somehow it evolved from AREF to VRE.
Got it.
Think about it, we share our homes with our dogs, we're hugging and kissing them, we're sharing our food, we're sleeping in beds with them. Sure, we're sharing our microbes with them, but they're invisible in this whole conversation about antibiotic resistance. The veterinarians know, the docs, nobody wants to hear of it.
But by the same token, you would think, how there's a lot of, information about kids who grow up on farms that are dirtier, that don't wash as much, people who live with pets, they actually have a stronger immune system. And that's tend to be regarded as a really good thing. And yet you can see that some of these bugs we don't want. And
it depends on the bug and the host. Right. Now, in their study, they found one 10-year-old boy who was colonized with this bug, but he wasn't sick. But if you have a grandparent living in the home, they might get sick. I mean, it all is host microbe interactions, who's vulnerable and who's not. And yes, in general, having them in your home is a good thing, unless you have some sort of, personal genetic either risk or you're immunosuppressed for some reason. We've got a lot of people with organ transplants who are on chronic immunosuppressive drugs. If you're diabetic, that's an immunosuppressive state. So, there's lots of, possibilities of what might make you more susceptible to some of these organisms than others.
Right. Like you said, it's the host microbe interaction that really makes the difference. Just like it's your genetics, your lifestyle, and your environment that all play a dance as to whether you become ill. It's not just one component. It's sort of this whole dance together.
Well, look at COVID-19. Some people are completely asymptomatic and other people are dying.
Right.
So it's your environment, it's your genetics, it's how much you're exposed to it. It's all those things factored together, and that's generally not how we practice medicine.
Right. No, I think it's really interesting. And coming from someone who's both a physician, a nurse, a master's in public health and assimilate and researcher, and assimilating all of that really makes you come up with some pretty hard truths that are going on right now. And
Nobody wants to hear.
I want to hear it. I want to hear it, Laura, and I will put it out there as much as I can because I think
you. I appreciate it. I appreciate it. You're one of the few physicians who's really interested in, there's a few physicians that get it. But
I'll tell you, I would be surprised. I think you would be surprised as how many people do get it, but they just don't have the ability to cross over. I mean, that's the whole silos of science and the communication and getting it into the mainstream public through people that are well known in health and wellness, whatever it takes. It's so much more than it was maybe even a few years ago. And so I really do have hope that people are going to be sharing these messages because they're critical, especially now. So,
well, your podcast is a great, venue, and I applaud you, and I am so grateful to you for, being able to help spread the word on really, critical issues.
Well, I just got started in this, but I feel like this is a really great place for people to listen comfortably, to really smart people share difficult topics in a way that makes people understand it clearly. So maybe that's what's been missing is sort of that communication of language, but or venue. But either way, I'm thrilled to have you. And so I think we're going to wrap up. But I guess I want to ask, to finish up is, how do people get involved? If you want people to really jump on this and get involved, how can someone, an average everyday person who's just trying to surviving and keep their job, get a job, send their kids to school, just live. How does someone really get involved with One Health and the mission that you have?
Well, I'll give you an example. There's a school teacher down in Louisiana. Her son was scratched by a kitten, and he developed Bartonella and has been sick, very sick for years. And so she's gotten really involved in One Health by contacting her legislators. She got, One Health Day in Louisiana passed. She's really engaged in trying to teach One Health to K through 12 students. I mean, there's a whole group of people that are dedicated to trying to spread the One Health word to kids. So there's lots of ways like I said, there's a huge veterinarian community that's really passionate about it. And so the public, whether you're a school teacher or any other kind of profession, nurse, everyone can learn about it and help spread the word about it, and try and educate your family, friends, and certainly notify your policymakers, your state and federal representatives that this is an issue that's important to you. And that you want to make sure that there's government support for it, and that we organize our government to better address it. That we have strong environmental regulations to protect our air, our water, and our soil. That we shouldn't be cutting back on these regulations. That we need to be protecting ecosystems and not just cave to corporate interests. At the expense of our planet.
And brings to mind, and I know you know this quote because I use it in our book, Non-Toxic, that's coming out because it meant so much to Dr. Vamsal and I when we wrote the book, that Margaret Mead, of course, wrote, she has a great quote. She's an American cultural anthropologist that was very famous in her work, but she wrote, never doubt that a small group of thoughtful, committed citizens can change the world.
Absolutely.
Indeed, it's the only thing that ever has.
Yeah.
And so, this is empowering to hear that even one person that you're described really had an impact. And we can all do that, hopefully, without tragedy involved. But
Absolutely. Absolutely. I just want to put in a plug for our One Health Initiative website. OneHealthInitiative.com serves as a global repository for all news and information pertaining to One Health. There's the One Health Commission website, which has a lot of educational resources, particularly K through 12. They're very committed to education of our kids and of the public. on these issues. Very rich website. I have a Coursera course now, Bats, Ducks, and Pandemics, an Introduction to One Health Policy. While it was developed and recorded before the COVID-19 pandemic, it's certainly, all the discussions are certainly relevant, and I incorporate questions and readings from the pandemic into the course. So that's
I am signed up for that Coursera course. I am. I just have yet to have a moment to listen to it. So I have vacation next week for a few days, and I'm hoping to do that. But I loved the topics that are listed for Coursera for that. And they can find that how can they find that course?
You just Google Bats, Ducks, and Pandemics and Introduction to One Health Policy, or you can Google One Health and Coursera. It should pop up. There's actually a European One Health Coursera course as well. I haven't taken it or reviewed it, so I'm not sure exactly what they're covering. Mine is 6 sessions, so it's very succinct, and it looks at One Health from the perspective of, particularly governments and what they should or should not be doing, or what they can or cannot do. So it covers it.
That's wonderful. No, I'm really excited. And also, I do follow One Health on Facebook.
Oh, terrific.
A very large following and really interesting contributors. So, yeah, all the social media. So, Laura, thank you so much.
Pleasure, Ollie.
It's always my pleasure to run into you. I know you moved a little bit further away from me, but we'll still grab lunch when you come into town to teach at Princeton. If we ever get back on campus. But I can't tell you how much I respect your work.
Thank you.
Your training and your voice in this really critical time when we need to hear voices from people like yourself who really have a lot to say and earned the right to say it. So thank you so much for being with us. And I look forward to working with you in the future and sharing your work with others.
Well, as one physician to another, we both understand the importance of the environment and the dangers of chemicals. So I applaud the important work that you're doing. And thank you again for helping to spread the word with this podcast.
Thanks. Okay, be well.
Yeah, you too. Take care.